Hello friends, today we are discussing regarding the stress concentration. In this stress concentration, we are going to study about some introduction about the stress concentration, what are the causes of the stress concentration, its remedies, and the difference between the failure by static load and by the fluctuating load. See, we always we are knowing that when a load it is been acting on a mechanical component, when its magnitude is being going to change with respect to the time, we call it as it is a fluctuating load. While when a load it is been acting on a component and its magnitude does not change with respect to the time, we call it as a static load. When a component it is been subjected to the static load, the stresses can be obtained by our simple equation, that is the load divided by area. In order to know what is the bending stresses acting on a component, we use the formula sigma b equal to the bending moment multiplied by y divided by I. In order to know what are the shear stresses that are being developed, or we can say that is the torsional stresses that are being developed because of the twisting moment acting on the component, we use the equation that is the tau equal to mt multiplied by r divided by j. Now these equations are been in a consideration that there are no any discontinuity present in the component. However, discontinuity and abrupt changes are unavoidable in our mechanical component. For example, we require the keyways, we require the shoulders, we require to have the oil holes, we require the threads. So all these actually acting as a discontinuity in the mechanical component, but these are unavoidable conditions in our mechanical components. Now if we will consider a simple plate that is being subjected to a tensile load. Now this plate will be having one hole at the center. Now when this plate it is been loaded by a load P, and if we will observe the stresses under by the photoelastic method, it is been observed that there are the highest stresses are been at the near the vicinity of this hole, and the stresses that we are being considered with the help of our the elementary equations, that is with the help of the sigma t equation or the sigma b or the tau, that stresses are been very less as compared to the stresses that are being observed near the vicinity of this hole. Now if we will use our the elementary equations in order to determine the stresses, these equations does not give us the correct results. So we have to consider a stress concentration factor in the design in order to consider the maximum stresses that are being developed near the vicinity of this hole. So this stress concentration that can be considered with the help of a stress concentration factor, that is the Kt. That Kt is nothing but the highest value of the actual stress near the discontinuity divided by the nominal stress that are being obtained by our elementary equations for the minimum cross section. Now this is a definition of the stress concentration, that is nothing but a localization of the high stresses due to the irregularities present in the component and the abrupt changes of the cross section. Now what are the causes of the stress concentration? First one, that is the variation in the properties of the material. See, we during our the elementary equations we always been considering that the material is the homogeneous. but in actual cases it is not the case. There are the internal cracks and the flaws like blowholes that are been present. There are the cavities in the hole wells. There are the air holes. There are the non-metallic or the foreign inclusions are there. So all these variations act as a discontinuities in the component and causes the stress concentration. The second one, it is your the load application. See, in our mechanical component, a very large load, it is been acting on a very small area. So the pressure at that point, it is been a very excessive. For example, the contact between the meshing teeth of a driving and the driven gear, contact between the cam and the follower, contact between the balls and traces of the ball bearings, contact between the rail and the wheel, contact between the crane hook and the chain. So at these applications there is a very large load that is been acting on a very small area, and at that point the stress concentration will be higher. The second one, that is the abrupt changes in the section. Now in order to mount the gears, the pulleys and the ball bearings on a transmission shaft, shoulders are always been necessary. Now all these things are been actually the necessary for our mechanical system, but these changes will act as a discontinuity and there will be the stress concentration. Again, the oil holes, the keyways, the splines will act as a discontinuity and there will be a more stress concentration at these junctions. The next one, that is your the machining scratches. These again act as a irregularity and will cause the stress concentration. Now how to reduce this stress concentration? Now if you will consider a simple analogy of the fluid flow. When the fluid it is been flowing through a pipe, we can get its, that is the discharge, with a simple equation, that is the Q equal to U into dA. While when a plate it is been subjected to a force, its force can be obtained with the help of the simple formula, that is the P equal to stress multiplied by the area. Now when the fluid it is been flowing through a pipe and a sudden reduction in the area of the pipe will happen, so during that case, in order to maintain the constant flow, the streamlines will be get narrowed and that will be become a very close to each other, and there is a sharp bend of the streamlines at the corners. Similarly, when a plate is being loaded with a force P, the stress lines will be get closer and there will be the sharp bend, and when the sharp bend will be occur of the stress line, there will be the more stress concentration. So in order to reduce the stress concentration, we have to reduce this sharp bending of the stress line. So in order to reduce the sharp stress lines, we will make a fillet at the corner, so that there will be the less bending of the stress lines. So here we are been providing the fillet in order to reduce the stress concentration. Again, in case of the next case, that is of a simple notch, we are been providing a number of notches in order to reduce the stress concentration. Here, instead of providing a wide notch, we will provide the narrow projection in order to reduce the stress concentration. So there are the many ways to reduce the stress concentration. Now we'll go to the next point, that is the difference between the failure by the static load and the failure by the fluctuating load. Now in case of the static load, before the failure of the static load, there is a sufficient plastic flow of the deformation prior to the failure, and which gives us a warning well in advance. That means a simple example is that when a specimen it is been loaded under the force in a simple tensile testing machine, in that case there will be a sufficient plastic flow of the specimen before the failure of a mechanical component. So in general, when a component it is been subjected to the static load, it will give us a warning well in advance. While in case of a fatigue failure, the cracks are being developed near the discontinuity of a component and that are not visible to us, and when they reaches to the surface of the component, by that time actually the failure has been taken place. So this is the difference in between the static load and the fluctuating load.